Good morning. I'm the last talk, keeping you from break, so I'll try to go quick, but I'm here to talk a bit about how we're able to leverage all this new technology that you heard about in the earlier talks in order to get a better gaming experience for our players. For those of you not familiar with Riot Games, we are the developer and publisher of League of Legends. League of Legends is an online multiplayer competitive game that pits teams of players against each other. Players choose from one over 130 champions. Each champion has a unique backstory and unique abilities that make them fun and engaging to play with. You group up in teams of 5 to compete for objectives on the map with the goal of actually winning and destroying the other team's nexus. We've been fortunate that our game's been very well received by our fans. The latest numbers that we've released, we have over 100 million monthly active players of League of Legends. And with that sort of scale, there are some challenges that we have to overcome. And one of them is a perception that the community in League of Legends is actually toxic. And so what we found, we wanted to combat this sort of perception, and so we actually dug in and looked, and when we asked our players, they all, 94.5% of them said that they believe that teamwork and sportsmanship is important to winning games in League of Legends. So this, as part of the player behavior team, this sort of set the stage for us to sort of take a twofold attack. One is sort of encourage players to do more teamwork and have more sportsmanship behavior, and then two, sort of punish the players who are repeat offenders and ruining the game for 9 other players on the field. So we dug deeper into this toxicity that occurs in League of Legends, and what we found is 2% of all games are infected by serious toxicity. And what serious toxicity here is, it's forms of hate speech, sexism, racism, and other forms of abuse that has no place in our game. And our hope was that if we could actually get rid of this toxicity, overall perception would improve. We wanted to see who was actually committing this unsportsmanlike behavior, and we found only 1% of our player base actually is consistently unsportsmanlike. And if we remove them from the game, how much of this toxicity would we see removed? Well, it turns out that 1% is only responsible for 5% of the overall unsportsmanlike behavior in the game. So this means that 95% is coming from players who otherwise are completely sportsmanlike. They're having either a bad day, a bad game, and they're going to say things that ultimately they regret. So this shaped how we actually wanted to take action against these players. We definitely don't want to remove them from the game, but we want to warn them that they need to change in order to be more sportsmanlike in League of Legends. For those of you not familiar with the game, this is a recent screenshot of League of Legends, and here there's a lot going on in this game. We're only going to focus on this lower left-hand corner where we have players' ability to chat with each other. So League of Legends is a real-time game, so players do not have a lot of time to stop, chat, write long sequences of text. In fact, they've adopted a notation of a lot of acronyms. So here you see one of our more sportsmanlike acronyms, GLHF, which stands for Good Luck, Have Fun. And things like this occur quite frequently. The other challenge that we face with natural language in League of Legends is this notion of the semantics of the words don't often correspond with their real-world semantics. So leash here is not referring to an actual leash that you would carry or you'd put on a dog or a pet. It's actually talking about Fiora's asking for help at low level in the jungle so that she doesn't die. So the leash has very different semantics for us. We wanted to actually dig into sort of the language used by our players. And for those of you familiar, Word2Vec has been very popular in the last 5 years. It relies on the distributional hypothesis, which states that words' meanings are derived by the context in which they occur. So here we have a context, I was out of, and we're trying to predict the word that'll fit that slot. Here, mana works, health, range, time, these sorts of words actually all fit there. And so the Word2Vec model is a neural model that actually takes these contexts and tries to predict the words that belong in them. We're able to leverage this right out of the box on our player data. And we trained up a model that had 256 dimensions for the embeddings. An embedding is effectively the semantics of the word. We grabbed a month of our chat logs. Each line of chat is a document, and we split on spaces and lowercase just to make our lives easier. And what we found was some interesting results from our players. The first is, as I mentioned earlier, we have a lot of acronyms that occur in game. And so here we have the similar words to GJ, which stands for good job. And you can see that there are some misspellings in there, some different ways of saying good job. Some players actually write out the full good job without a space. But we also get some other things. So this may look like an acronym, but in fact, QQ is more like a meme. So its origin is back in Warcraft 3, where players would tell another player QQ, which was a command for Alt QQ, quit the game because you're bad. So this is the less sportsmanlike behavior. What's interesting, though, is the community over time, this word is not very old. It's only about 5 years old, but its meaning has drifted over time. And so now, actually, players, when you look at QQ capitalized, it looks like crying eyes. So it can also be used for a sad emoji. And you see that both meanings captured by Word2Vec here. The third one is another unsportsmanlike term. It's commonly used for players who are not very good at the game or new in the game. And what's interesting here is Word2Vec is actually able to capture for us all the different misspellings of noob. And there are many different misspellings. This is incredibly useful if you want to build up a blacklist of words that you don't want players to use. So here, they're typing very fast. They're doing it in different ways, but the contexts are giving us the meanings that we need. And the last one, our player base is younger than I am, so often we encounter words that we don't fully understand. And Word2Vec is actually able to help us figure out what the players are saying as our language shifts over time. So here, many of you probably are not familiar with the term rect, but we can look through the list of similar words and sort of try to tease out the meaning as the player uses it. And in fact, wrecked is when one player handily beats another player, or one team handily beats another opponent, and you can see that sort of in owned and roasted. So our team, a couple years ago, actually developed and built a model that would predict toxicity in-game. We shipped this model. It was trained on desktop, written in R and Python, and we got it out into production. And that is critical for us because immediately that means we're seeing less player pain worldwide. Since it's launched, it's punished over millions of players for bad behavior in-game. One other thing that we actually had to really do is we had to come in with extremely high precision. As I mentioned, we have 100 million monthly active players. That means that millions of games are played every day. If you punish a player when they're not using toxic language, it feels even worse than actually not letting them through. And so we had to err on the side of caution and ensure that we had very few false positives. Some of the challenges with this model was that we had to limit our data. Since it was trained on a single model, we could only do what could fit in memory. And then, since we over-indexed on super high precision, we limited the amount of recall that we could get. So this last quarter, we spent some time investigating alternatives, looking into Apache Spark to see if we could improve the performance of this model. And then lastly, with the excitement around deep learning, we looked what we could pull off with GPUs and TensorFlow. So our motivation for why Apache Spark, as I mentioned, we limited the amount of data. And it's a well-studied result that more training data leads to better performance on your algorithms. And here, this original work was back in 2001 by Banco and Brill and Microsoft Research, where they simply showed that as you scale up the millions of words that you add to your training data set, your performance goes up. We replicated that result with our own data set. So here we varied the amount of training data we gave to the model. I think the only difference between the Banco and Brill result and ours is that we actually performed a hyperparameter search for each amount of training data so that we ensured that this was the best possible model for that amount of data. And what you're looking at here is a precision recall curve at varying amounts of training data on the same test set. And what's interesting here is that we're able to show that more training actually helps. But when I joined the team, what caught me off guard was the shape of this precision recall curve. It feels bad in some sense because it doesn't go out and down, it instead drops quickly. And when we dug into this, what it actually is our players can report other players for toxic behavior. And that is the training signal that we use to actually detect toxicity, so it's community driven, but it's also the thing we use to predict that test time. And the challenge here is that what's toxic to one player may not be toxic to another player. And then, not only that, you have the problem of a player who has received some extreme abuse as they leave the game may not want to engage and take the time to report that game. They just want to be done with it and away from it as quick as possible. So when we moved forward with this, the first thing we did was actually go out and build a new golden data set. And we'll probably in the future look at some of Chris Ray's work on Snorkel. So this gave us the evidence we needed to believe that running this out on Apache Spark would be useful. We could scale out our model complexity, and we could scale out our training data size. One of the nice features of Spark is the built-in libraries that come with the machine learning library. So here we're able to vary many different features. So we can change out our transformers, we can try out unigrams, bigrams, trigrams, we can change our tokenization method. You've seen we've used word2vec and we use some TF-IDF. And then lastly, we can quickly iterate through many of the different algorithms that are implemented, looking to sort of maximize our precision and recall. And here we have another graph that shows a sample of those algorithms that we actually ran through the model. We've got bag of words, random forest, some TF-IDF with bag of words. We looked at many more things, but the curve has improved now that we have a golden data set. This data set is actually whether or not we want to punish the player, and then sort of what level of severity of punishment we want to give them. So we were able to very quickly try out many different things. We see that we get one precision up to some amount of recall, and so it gave us confidence that we could start tuning our parameters and actually punishing more players. The other algorithm up here that sort of motivates the next set of slides is a convolutional neural network. So we were excited to see what convolutional neural networks could get us, because League of Legends is a worldwide game. Our servers are located here in North America for our North American players. They're in Chicago. There's no restriction on what language you can speak when you play League of Legends in our North American servers. And in fact, what we found when we launched our latest set of servers in Japan is that many of our Japanese players had been playing all along in our North American servers. So you can imagine that we have a mix of Japanese, some French-Canadian, and then some Spanish from Latin America, and then English is the predominant language here. The other challenges that we face for Japan is that many players are coming from Korea and China to play on Japanese servers. So as someone who actually has to model this language and detect toxicity, it gets really challenging because players can switch which language they're using in-game. So they can start out talking with their friends in their native language, but the other team may be speaking a different language, and so they can actually chat with them in that. And so detecting language and actually dealing with that language is very tricky. So we looked at GPUs. We were motivated by this work from Zhang and Wallace in 2015. The idea here was, rather than predicting sentiment, we're going to predict toxicity. Rather than using words, we're going to use characters. This would allow us to train up a global model off of all of our training data. It removes this tokenization problem where we have to figure out if it's a character-based language or if it's a word-based language. So it simplifies all of that. The challenge, as anyone who's worked in deep learning knows, is that there are a lot of different hyperparameters that we need to look at. So just in that model, we can vary the amount of vocab that we're going to allow, the window size. So here we're actually looking at 1,000 characters that we send in through our convolutional neural network, the stride that we move that window across. Our convolutional layers are actually a convolution plus max pooling, which helps reduce dimensionality and enable some better generalization. But how many of those do we want to stack together? We also need to vary the window size, so how many characters do we consider for one convolution, and the number of feature maps. And then lastly, in that previous slide, we have a fully connected set of layers at the end. How many of those do we want to do? How many nodes do they need? So there are a lot of different hyperparameters to look for. So this is where we could actually leverage Apache Spark. And this follows on from Tim's demo earlier, where we actually leverage Spark to do the hyperparameter search for us. So here we're not sending data out to worker nodes to be processed. We're actually sending a model specification out to each worker. Then that worker will go out, read training data from S3, fit a model, grab validation data from S3, evaluate that model, save all the results out to S3, and then report back how they did. So here the driver then aggregates sort of performance metrics, and you can select the model that's performing best on your validation data. And this sort of allows us to scale out this hyperparameter search and not have to build up our own infrastructure to do it. So in conclusion, Spark has helped us shield our players from extreme toxicity in games. We've punished millions of players. We're going to continue punishing more in hopes that they will learn and not be toxic in game. It has allowed us to rapidly explore the space of solutions that we want to deal with. So here we could very quickly try out different combinations of algorithms, tokenization, and parameters. We can scale to far larger data sets than we could process before, which has allowed us to improve performance and confidence of our algorithms. And then lastly, we can scale these hyperparameter searches across neural network architectures. So with that, if you want to find me, ask me questions, I'll be around. Or you can reach me at my email address, wkerr@riotgames.com. But thank you and enjoy your break.